Welcome back. We're going to kind of switch gears from going from continuous and discrete relations, and we're going to talk about something called function notation. We defined functions in the last two learning targets, but now we're going to connect that to what a function equation looks like. So we're going to start by reviewing what evaluating means. Remembering that evaluate means you're finding the value. So it means that we're going to take this x equals -2, and we're going to plug it in for the x here. We're going to use parentheses always. So always use parentheses. When substituting, which kind of is the same thing as plugging in. Let me spell it correctly. So it's the same thing as plugging in the value. So the way I'm going to write this is I'm going to say 2, put my parentheses, and I'm plugging in -2 squared minus 5. Remembering order of operations says we have to do these exponents first. So we're going to keep the 2 in front, keep this in parentheses, and we're going to, if you're not sure what -2 squared is, you can always use your calculator. So if I go to my calculator, I'm going to use parentheses -2, make it squared by hitting the tilde button, or I can hit the x squared button either way, hit enter, and I get 4. So now I'm going to go back to here, and I'm going to plug in 4, and then -5. Now I do multiplication to get 8 minus 5, and 8 minus 5 is 3. So I evaluated that expression when x equals -2. So that's a review from order of operations. So how's that related to function notation? Well, if I were to go to function notation, which is a new concept, I can write an expression like 4x minus 1, but I'm going to write it in a different way. We're going to say instead now, function notation, we can replace that y with something that's called f of x. So f of x means the same thing as y. It's just a different way we write it. So if we say y equals 4x minus 1, we can rewrite that as f of x equals 4x minus 1. And we're reading this as f of x equals 4 times x minus 1. That's how we read that out in English. Okay, so it's just a different way to translate an expression or an equation. We also want to say here and know, and this is a review from last lesson, that x is the input of a function, and y, oh, sorry, not y, but we're going to rewrite it as f of x, means the same thing as y, and f of x is my output. So this right here, let me go over here. This here is my input, and this here, oh my gosh, this here is my output. It's just written in a different way, f of x instead of y. So if now I want to evaluate using function notation, example 2 says if f of x equals 4x minus 1, find f of -7. So what this looks like is remembering that from just a second ago, this is my x value inside the parentheses, and this is also my x value inside the parentheses. So what we're going to do is instead of f of x, we're going to say now f of -7. We're plugging that x, -7 in for x. And it's going to equal 4, replace again that x with -7, and continue that -1. Now we're going to evaluate. Okay, we're going to find that f of -7. So I'm going to keep f of -7 on the left. And now I'm going to do order of operations here. 4 times -7 is -28. Bring down that -1. And when I finish the math here, -28 minus 1 is -29. So this is evaluating, so I can say f of -7 equals -29. So I'm just creating a new notation for, instead of saying y, I'm saying f of x, f of whatever I plug my input into. Okay, so If we determine that f of 7 equals negative 29, there now exists a coordinate pair, and this is important, of negative 7 comma negative 29. Because this right here is my x value, and what I got was my y value. F of 7 is negative 29. When I plug in x, I get negative 29, so that negative 7 is my x, and my negative 29 is my y. This looks the same as f of x equals y. X value inside the parentheses, y is what we get when we plug it in. F of x equals y. So example 3, evaluate, we're gonna put all this together. Example 3 says evaluate negative 3x plus 1. Remembering that evaluate means that we're trying to find the value of this. So I'm looking here at f of 10. So I'm going to look at the top 4 equations, and look, I find f right here. So that's the function I'm going to use. So f of 10 equals, oops, I did not mean to use the highlighter. Let's go back here. So that means that f of 10 equals negative 3. We're plugging 10 in for x plus 1. So f of 10 equals negative 30 plus 1. So f of 10 equals negative 29. Now I can write this as a coordinate pair of 10 comma negative 29. Okay. I can also put in direction here is find the coordinate pair. Should have put that in the directions. Okay. So letter B, example B. Now instead of using f, I'm going to go ahead and use g, which matches this function right here. So now I'm going to say g of negative 6 equals x squared. Oh, not x. We're going to plug negative 6 in for x squared plus 7. Remember when we plug in, we use parentheses. Keeping that g of negative 6. Negative 6 squared, again, if you're not sure, use the calculator. Plug in negative 6 squared, and I get positive 36. So this is going to be positive 36 plus 7. So g of negative 6 equals 43. That creates a coordinate pair at negative 6, 43. Oh, I see where that coordinate pair piece was. I should have put it right here and here. Look at me. So that's what that coordinate pair part is. I should have written it there. I will do that on the next example. So now the next example, we're using h. So we're going to highlight h. We're using h. So when I plug this in, I'm going to say h of negative 2 equals 1/2. Plug that 2 in parentheses. So this is just 1/2 times, oh, it's negative 2. Wow, I'm making lots of mistakes here. So it's 1/2 times negative 2. And if you're not sure again what that 1/2 times negative 2 is, go ahead and plug it in your calculator. When you plug in 1/2, remembering that that 1/2 needs to be put in parentheses to do it correctly in your calculator. So I'm going to go ahead and use parentheses 1 divided by 2 times negative 2. I'm going to get negative 1. So now I know that h of negative 2 is negative 1. I can write that as a coordinate pair as negative 2 comma negative 1. That's my x, that's my y. So x and y. And my last example here, if I can get my highlighter to work, I'm looking now at the equation j, the function j, which is this last one. So j of 7 is going to be 2 times 7 plus 9. Keeping that j of 7, 2 times 7 is 14, and 14 plus 9 is going to give me 23. Excuse me. That coordinate pair, that 7 is x, that 23 is y, so I have a coordinate pair at 7 comma 23, my x and my y. Okay, so that is evaluating, finding coordinate pairs of an equation, of a function. Okay, we can also look at finding coordinate pairs using function notation for a table. So tables is something that we did in the last lesson when we found our x and find our y, but sometimes it's not always listed as x and y in a real world problem. So I'm putting a real world problem in here, and that's about temperature and about time. So temperature readings for boiling water are taken each hour and are given in this table below. In this scenario, the temperature T is a function of the number of hours H. So when we could rewrite this as saying that this is x right here, and this is y, because remembering that t of x equals y, and so the same thing here is t of h can equal y if we write these as a coordinate pair. So like for this point, this would be 0, 212. That would be that coordinate pair if we're looking at this table and defining it. So let's look at what I'd like you to be able to do in these problems. So A says evaluate t of 2 and t of 6. So if we look at this, we're saying that this is our x and this is our y. Oops, sorry. This is our x, and it's asking you to find y. So t of negative 2, again, that's our x. What is our y? Okay, so we can say evaluate, and we can say what is y. So if I go to t of 2 and find out where 2 is right here in my x, and what's its matching y value? 104. So that creates a point at 2, 104. We also need to find t of 6. So t of 6, that's our x again. We can also say this is h, right? If we're using a real world problem, we're really saying at 6 hours, what is the temperature? Well, at 6 hours, the temperature is 68 degrees. So I have a coordinate pair at 6, 68. This is h and that is t. So 668. Now let's go the other way. The other way says for what value of h is t of h equal to 76. So now here, it's asking for the y value. Oh, sorry, asking for the x value. On the first example, we were looking for that y value for the temperature. Now we're looking for the hours. So the temperature is 76 degrees. What is the hour? So I'm going to go find 76 in my y and my temperature, and then I'm going to look to see what my hours are. My hours are 4, so I can say that t of 4 now equals 76. So at 4 hours, it's 76 degrees, and it says for what value, so we want to say that h equals 4. Because that's the value. Tables can be a little tricky, especially in a real world problem, but that's what we're looking for in math, really. And I haven't used a lot of examples of real world problems, but I want you to be exposed to it so you kind of understand where we're coming from. The last thing that we need to be able to do is using graphs for function notation. So we have function notation as f of x equals y, again, represents that coordinate pair. We're always going to keep that in mind. So example 5, find the coordinate pair using function notation, and we're looking at a graph for this. So remembering again, I'm going to repeat myself a lot here, that inside the parentheses is your x, and after the equal sign is your y. So this is saying, hey, if x is 1, what's my y value? So I'm going to go to the graph and find x equals 1, which is right here. And what is its y value? If I draw an arrow up, boom, there's the y value. That's going to be at 1, 2, 3, and 4. So my y value is 4. And since I'm looking for that coordinate pair is 1, 4. Let's look at the next problem. So now we're saying, hey, x is 5. What is my y value? So if x is 5, I'm going to count over 1, 2, 3, 4, 5. There's x equals 5. What is my y value? Go over to here. My y value is 1, 2, and it's going down, so that's negative 2. So I have a coordinate pair at 5, negative 2. So f of x equals negative 2, coordinate pair at 5, negative 2. The next example says f of negative 3. So that's my x value, looking for what the y value is. So I'm going to go to x equals negative 3, which is right here. Look down now to where my y value is, right here. Count downwards. 1, 2, 3, 4. So f of -3 equals -4. So I have a coordinate pair at -3, -4. Then I have the last example of f is 0. So I have my x, I'm looking for my y. So this one's a little trickier. Remembering that x equals 0 is right here at the origin. I'm going to go up to find the y value. It's right there at 1, 2. So f of 0 equals 2. So I have a coordinate pair at 0, 2. So that is looking for the y values if you're given the x values in function notation. What happens next is if we have, I'm going to erase this, is now this says find x when f of x equals 0. So now I know my y value, but I don't know my x value. So this problem is saying, hey, when y is 0, what is x? So we're looking for x. So I'm now going to find y equals 0. Y equals 0 is right here at the origin, right? Because that's the coordinate pair 0, 0. Y is 0 here, right? So now I'm finding x. Well, my x value when I wrote that coordinate pair is right here also at 0. So, when I wrote this coordinate pair, it was 0, 0. That found the y. And now I'm looking for my x value. So my x value is, I'm so sorry. This is the coordinate pair 0, 0. So my x value is 0. Okay, that's what we're looking for. So I apologize there. So f of 0 equals 0. So my x value is 0 here. Apologies if that was confusing. If you're not sure what I just said, please come ask me for help. I know that was a little bit of a mistake. So I'm looking for x there when y is 0. Same thing for this next example. I've got find x when f of x equals 2. So y is 2. And now I'm looking for whatever x is. So y is 2 is right here. So y being 2, what is my x value there? Well, my x value is going to be 0. So I have a point at 0, 2. I actually did make a mistake on this example right here. So I'm going to go back and redo that example. Sometimes I make mistakes, and I've got to fix them when I have. Okay. So let's go back here. Okay. So now I'm looking for x when f of x equals 0. So when y equals 0 right here. So now I'm looking for that x value, and my apologies here. Okay, so y equals 0 is right here. Now I'm looking for the x value. X value is right here because it goes to the right, and that x value is 4. So I can say f of 4 equals 0. So I have a coordinate pair at 4, 0. Okay, again, apologies for the mistake. I do make mistakes in videos, and I do have to go back sometimes. So please bear with me and understand that I am human, and it does happen sometimes. So again, if you are confused, wasn't sure what I did to correct this, please come ask me for help. I understand that I do make mistakes at times, just like everyone. So that's how we use function notation in equations and plugging in and substituting, how we use function notation in tables, and how we use function notation in graphs. Please ask for help if you need it, and good luck.